what I'm saying here is the applications which are created by C and C++, those are platform dependent. Means once you create, once you compile, you cannot execute them on different platforms. You can only execute these applications wherever, on whichever corresponding platform it created. If it is created in Windows, compiled on Windows, run only on Windows. Whereas in Java, if you compile your application once, irrespective of any platform, can be executed on different machines. You can execute that on Windows, you can execute that on Linux, execute that on Mac. How it is possible? That's what the major question. That's what the important question here is. This is all possible because of JVM and the bytecode. This is all possible because of JVM and the bytecode. I'm going in detail of what this bytecode stands for and how is that possible. Showing you the different phases. This is compilation. You have, say, platform 1, platform 2, platform 3. And on this platform, you have something called as JVM. Okay, so what this JVM stands for? So what I'm drawing here is your Java application, my application.java, which is compiled. So what you got is my app.class file. So this class file, once you get your class file, this class file contains bytecodes. So when I say bytecode stands for zeros and ones. So now tell me, can I say zeros and ones are easily understandable to the machines? Because at the end, every machine understands zeros and ones. Irrespective of the platform that you're using, every machine understands zeros and ones. So what Java is doing, what Java's compiler is doing, Java's compiler is converting your Java file. After compilation, it is giving you a .class file, and that .class file is zeros and ones. It's a bytecode, and this bytecode is readable by any platform. So this is your Windows, this is your Linux, this is your Mac, and what you have here is a JVM, Java Virtual Machine. Give me a second, I will talk about that, what exactly you mean by JVM. Okay, now you can just assume you want to travel to a different country. So from here you are going for a tour. Say you went to a Japan, and once you go to a Japan, but you don't understand Japanese, isn't it the problem? What you know is Hindi, what you know is English. What platform understand is Japanese or Chinese. Then don't you think that we need some translator in between? What I know is English, what platform requires is Japanese, Chinese. So the translator is required in between, right? So this JVM works as a translator. This JVM works like a translator. So this JVM reads this bytecode, and converts this bytecode into a machine language. Machine language means instructions. Now tell me, these instructions, as I told you, we used to write the instructions in 40s, in 50s, in 60s. You remember I told you binary language, assembly level language, COBOL, Pascal, Fortran. So these are the languages where we used to write the instructions, where we used to write the binary language, so that we used to give the instructions to the hardware directly. Now what we are doing is the same thing, but we handed over that responsibility to a JVM now. So now JVM, that is Java Virtual Machine, this JVM is a translator which takes care of converting your Java application, compiled application, .class application into an instruction. I'm still going to talk about JVM in detail, but I hope you are able to get the basic idea how it is happening. What we say, Java is compile once and run many times. When I say compile once, run many times means what? You create your application once, make sure to compile. Once you compile, once you get the .class file, you can run this as many times as you want on different platforms. Even on Windows, Linux, Mac, Android, whichever platform that you want, you can execute this. You don't have to create an application again from a scratch for different operating system. Getting it? That's the first thing. Whereas JVM is platform dependent. Your Java is platform independent, but JVM is platform dependent. Your application created is platform independent. Understand this. Application created is a platform independent. A compiled application is platform independent. But JVM is platform dependent. Don't you think that? JVM is just a software installed on top of operating systems. So for Windows, I need exe. For Linux, I need .sh. For Mac, I need .dmg. So these are just the softwares installed on your platform. Just to give you a simple example, I want to listen to music. I want to play a music. So if you want to play a music, you will need different players on different machines, right? On Windows, you will need vlc.exe, a media player, Windows media player exe. On Linux, you will need GOM player sh. The software will be different, right? Song remains same. The MP3 remains same. MP3, MP4, AAC, that remains same. But the software changes. That's why we say a Java compiled application is platform independent, but JVM is platform dependent. Does this make sense?